So now let's move to the first team. Okay, so for the first experiment, we are very happy to have Chong and Choi from the Hong Kong International School. The title of their presentation is Making a More Realistic Fire Extinguisher.
Hello, my name is Chong. I'm currently 16 years old.
Hello, my name is Choi. I'm currently 15 years old.
We are both 10th grade students studying at Hong Kong International School.
And we are also both learning AP Chemistry.
My role in this experiment was as the organizer. I helped to film the experiments and also create the presentation.
My role was the experimenter.
So our experiment was aimed towards 10 to 12-year-old chemistry students, as our topic was focused on urban living. It was for them to further understand the concept behind a fire extinguisher, and later on in the lesson, have the opportunity to make their own more realistic fire extinguisher. We chose this as our topic because fire extinguishers play such an important role in our lives, where we can walk into any building and almost always see one there. Yet many people do not really understand the concept behind a fire extinguisher. Through this experiment, students will come away with having a deeper understanding about neutralization reactions, reaction rates, and combustion, and how all three can be incorporated to allow a fire extinguisher to function.
So our kids lab experiment plan will be split into 4 different parts. We will first start off by teaching students about the requirements of combustion. We will then allow students to see how the reaction between vinegar and baking soda changes as we change the state of baking soda. Finally, the students will be given the opportunity to make their own realistic fire extinguisher and observe its utility.
In order to better understand the function behind a fire extinguisher, a background in combustion needs to be given to the students. In order to do this, we will show the fire triangle, where 3 elements are needed for combustion: heat, fuel, and oxygen. We would go on to explain how lacking one of these would result in extinguishing the flame. For example, if you were to pour water over a flame, or if a matchstick were to run out of fuel, it would result in the flame being extinguished. In the same way, if a glass cup was placed atop a flame, it would result in the flame being extinguished because of the lack of oxygen. Through this would be effective in providing the basic information associated with combustion.
So the second part of the experiment will teach students about the qualities of a fire extinguisher. We will prompt students to think which of the 3 elements of combustion a fire extinguisher removes when putting off a fire. Responses could include removing the supply of oxygen, removing the supply of fuel, and lowering the temperature. We will then continue to explain that a fire extinguisher removes the supply of oxygen by making CO2 gas through neutralization. We do understand that neutralization is a very hard topic for 10 to 12-year-old students to understand. Therefore, we will not go in depth on this concept, but instead briefly touch upon it by simply saying that the vinegar, the acid, with baking soda as a base will produce CO2 gas. Another quality we wish students to understand is the fact that a fire extinguisher needs to have very high pressure to work. Since when you're extinguishing a flame, you have to be very far away from it. A fire extinguisher needs to have the capability to force CO2 gas over a substantial distance. We hope this will allow students to understand why a fire extinguisher is made out of metal, a sturdy material, instead of plastic, for example, malleable material, which might be damaged due to the high pressure inside the fire extinguisher. Lastly, we would like students to understand that a fire extinguisher needs to have a very fast reaction rate. It needs to produce CO2 gas almost immediately after being used to extinguish a flame.
Next, we would go over the actual reaction speed experiment, where vinegar and baking soda would form the solid sodium acetate, carbon dioxide gas, and water. The important takeaway from this is that carbon dioxide gas is produced. To portray the effectiveness of carbon dioxide gas produced, we will conduct 2 different experiments. One in which solid baking soda reacts with vinegar, and the second where the baking soda has dissolved in water and reacted with vinegar.
So this is the result of our experiment between liquid vinegar with solid baking soda. As you can see from the graph on the left, you can see that the maximum carbon dioxide produced is roughly about 440 millimeters, and it starts to slant off from when the amount of baking soda reaches 2.0 times. And please note that when on the video, I have to continuously shake the triangular flask in order for the reaction to occur. So this is the experiment between the liquid vinegar and liquid baking soda. The two experiments were identical, except for the fact that we dissolved the baking soda in 20 mL of water. And if you see at the beginning of this video, the instantaneous rate in which the amount of CO2 gas is produced in the first few seconds of the experiment is much more than the previous experiment. Since carbon dioxide dissolved in water, this is not an accurate measurement of carbon dioxide, but this reaction was aimed to show students about the difference between the states and how the state changes the reaction rate. So from this, we can take that liquid plus liquid reaction much more effective in producing even more CO2 gas and at a much faster rate. So these are the steps that a student needs to take to make their own realistic fire extinguisher. So the design of our fire extinguisher was purposeful, as we used materials that can be frequently found around us. For the main frame, we used a plastic bottle, and to hold the two liquids, we used two paper cups. The reason why we used a balloon, and we poked, I'm not sure if you can see it clearly, but we did poke holes on the top lid of the plastic bottle. This, if you can see in the final part of the video, this indicates to the user that the plastic bottle has been completely filled with CO2 gas. The reason why we didn't fully enclose the bottle was due to the fear that if the pressure got too high inside the bottle, then the plastic bottle may explode, which would cause a danger to safety. So if you notice in the final part of the video, I have my finger covered at the top to prevent any gas or liquid from leaking. And if the slow motion video, you can see that the balloon tilted expands, which indicates to me that the bottle is completely filled with CO2 gas. This acts as a simulation for what a realistic fire extinguisher would be like.
So compared to the more well-known miniature fire extinguishers, our fire extinguisher has a much higher pressure, resulting in a much faster reaction rate. It helps provide a deeper understanding about a fire extinguisher's purpose and helps to incorporate chemistry in real life. As for the safety aspects regarded in this experiment, all fires will be done for demonstration purposes only inside a sandbox, with a fire extinguisher nearby in case of emergencies. All chemicals used in this lab are completely edible, so in the case that a student might ingest some, it would cause no harm towards them. This allows students to have a full hands-on experience in learning about chemistry. Thank you.
BASF. We create chemistry.